All right, we're going to talk a little bit about symmetry. Now, in general, symmetry means having some type of similarity. There are several different types of symmetry. We're going to focus on two kinds of symmetry. The first is line symmetry. So line symmetry basically says, if you draw a line somewhere, the two halves on either side of that line should match up. So for example, if I were to draw a heart, and you're going to pretend that I drew a perfect heart, which I obviously didn't, but in theory, a heart has line symmetry right down the middle. Right now, if I drew a perfect heart, if I fold it in half, the two halves of that heart would match up, and that's line symmetry. Now, the other type of symmetry is rotational symmetry. So rotational symmetry means if you spin something, it's going to look the same before you've gotten all the way around. So what might that look like? Well, let's look at an example of rotational symmetry here. So hold on while I draw this. All right. So this is an example of something that has rotational symmetry. It also has line symmetry, but rotational symmetry, if I rotate this, it looks the same at each of the places where I pause, even though I haven't rotated it the full amount. So that's rotational symmetry. Now we want to talk about symmetry as it relates to functions, or at least graphs. Not everything we talk about today will be a function. So let's start by talking about line symmetry. And when we're talking about graphs, we're going to look at line symmetry in two different ways. We're going to focus on the two big lines that we see when we're dealing with a graph, right? So the two big lines that we see are the y-axis and the x-axis. Now, something that we sketch could have y-axis symmetry, okay? So what type of thing might have y-axis symmetry? Well, here's a nice example. Okay, this is a parabola, or the graph of x squared, and this function has y-axis symmetry. Why? Because if I fold it in half along the y-axis, the two halves of this function would match up. Okay, so y-axis symmetry. When something has y-axis symmetry, we also say that that function is even. And where that comes from is if we look at something like f of x equals x squared, which is an example of a function that has y-axis symmetry, its powers here are even, okay? It gets a little bit deeper than that, but for us, that's what we need to know. Y-axis symmetry means our graph is symmetrical about the y-axis. In other words, if I fold it in half about the y-axis, the two halves would match up. Now there's another line that we often work with when we're dealing with our Cartesian coordinate system or our rectangular coordinate system, and that's the x-axis. So we can't have x-axis symmetry, right? That would just mean something is symmetrical about, I can't write and talk, something is symmetrical about the x-axis. So for example, if I drew something like this, right? This blue line is symmetrical about the y-axis. If I fold it in half about the y-axis, the two halves would match up. Okay, so this has x-axis symmetry, but what do you notice? Is this blue graph a function? It's not, right? It fails the vertical line test, which says a vertical line drawn anywhere can't pass through two or more points of the function. Well, this is definitely passing through two or more points of the function, which means we have one domain element mapping to two range elements. So this is not a function. So graphs can have x-axis symmetry, but a function will never have x-axis symmetry. Okay? We're going to focus more on y-axis symmetry because many functions have y-axis symmetry. Okay? And now let's talk about the other type of symmetry, which was rotational symmetry. Okay? So when we're dealing with graphs, we also sometimes care about rotational symmetry. And the interesting thing with rotational symmetry is thinking about what point are we going to rotate about. So in general, when you think about rotational symmetry, right, you're pinning a point and kind of spinning around that point. Okay? And the most obvious point for us to pin, so to speak, is the origin. So the origin, remember, is where the x and y axis come together right here. So what types of things have rotational symmetry, or also known as origin symmetry? So for us, when we're dealing with a graph, we're looking for rotational symmetry about the origin, or we just shorthand say origin symmetry. Well, here's an example of something that would have origin symmetry. Okay, now I can't spin this board right here So let me get my little board out and let me draw that same graph on my little board, and let's see if we can see that it has rotational symmetry. So remember, the big idea with rotational symmetry is if I rotate this, eventually it's going to look the same as it did before I went all the way around the full circle. Well, it doesn't look the same there. Ooh, but I think it looks the same there, right? So if I go halfway around, so here's where we started. If I go 180 degrees or halfway around, this looks the same. This means this has rotational symmetry or origin symmetry, okay? Now this particular example is the graph of x cubed, the cubic function, okay? So a couple of other things, y-axis symmetry, line symmetry, we say it's even. An example of that is x squared. Rotational symmetry, origin symmetry, okay? That means rotational symmetry about the origin, meaning if we spin this, it looks the same. Functions that have origin symmetry, we often refer to as odd. And you'll notice that our power here is odd. That's related to all of that, okay? So 3 different kinds of symmetry that we talked about. Line symmetry, y-axis symmetry. We also talked about x-axis symmetry. And then rotational symmetry or origin symmetry. All right, I've drawn 3 other graphs up here, and I just want us to review and think about what types of symmetry these graphs have. Do they have y-axis symmetry? Do they have x-axis symmetry? Do they have origin symmetry? Now, a graph may have all of these, and it may have none of these. Let's take a look. This graph here, the blue line, y-axis symmetry, x-axis symmetry, or rotational origin symmetry. Well, if I fold this in half along the y-axis, the 2 halves will match up. So this has y-axis symmetry. Let's check. X-axis symmetry? Certainly not. And origin symmetry. Well, if I were to spin this graph around, it's not going to look the same until I've spun all the way around. So this only has y-axis symmetry. How about this guy? Y-axis symmetry, x-axis symmetry, origin symmetry, or no symmetry? Well, this certainly doesn't have y-axis symmetry. If I fold it in half along the y-axis, I wouldn't get any type of symmetry. X-axis symmetry, yes, this has x-axis symmetry because if I fold it in half along the x-axis, these 2 halves would match up. So this has x-axis symmetry. And how about origin symmetry? Well, if I stuck a pin in this and were able to spin this graph, this wouldn't look the same until it had come all the way around. All right, last, let's look at this guy. Certainly doesn't have y-axis symmetry. Doesn't have x-axis symmetry. But if I were to spin this around, it would look the same halfway around. So this has origin symmetry. All right, so notice that this is a function and this is a function, but this is not a function. Anytime a graph has x-axis symmetry, it's not going to be a function. All right, 2 more examples thinking about symmetry. So let's look at this first graph. Now this is not a graph of a function. It would fail the vertical line test, but we can still talk about symmetry. So does this guy have y-axis, x-axis, or rotational symmetry, or maybe no symmetry? Well, if we look at the y-axis, if I were to fold in half along the y-axis, the 2 halves of this graph would match up. So this graph has y-axis symmetry. How about x-axis? If I were to fold in half along the x-axis, the 2 halves would match up, again with some, wiggle room for my imperfect drawing skills. So this guy has x-axis symmetry. And then how about origin or rotational symmetry? If I stuck a pin in this graph and spun it around, would it look the same before I got all the way around? Well, I think it would. I think it would look the same if I got halfway around. So this guy also has origin symmetry. All right, so this guy has all 3 types of symmetry that we've talked about: y-axis, x-axis, and origin symmetry. Now let's look at this last graph here. Okay, this is the graph of a function. It passes the vertical line test. But what about symmetry? Does this have y-axis symmetry? If I fold in half along the y-axis, no symmetry. If I fold in half along the x-axis, nope. Origin symmetry, if I stick a pin in this and spin it around, my function won't look the same until I've gotten all the way back around. So this guy has none of those symmetry. No y-axis symmetry, no x-axis symmetry, and no origin symmetry. Now, as we move on, we will see that this does have symmetry about itself. So for example, if I drew a line right here and folded along that line, the 2 halves of this function would be symmetrical. That's known as the axis of symmetry, and we'll talk about that a little bit later. But in terms of the 3 types of symmetry we've looked at, y-axis symmetry, x-axis symmetry, and origin symmetry, this purple graph doesn't have any of those.